what can we do with this? We can draw a picture. So since we're going from 0 to 360 degrees, we should draw a full circle rather than say just quadrant 1. Throw in your best y-axis, x-axis, good enough. And let's think about where 190 degrees lives. So let's see, 0 degrees, right? We always start our reference angles or our standard angles at the positive x-axis, and we go around counterclockwise. And so 180 degrees would be half of a revolution around here. So 190 is just a little farther than that. So 190's got to be over here somewhere. I'm guessing that's about 10 degrees further. So right here, we have 190 degrees. And let's say this is the unit circle. So we have a radius of 1. It's -1 over there, -1 down there, +1 over there. We are working with the sign here, and the sign is y value on the unit circle. So that means the answer to this right here, sine of 190 degrees, is whatever the y value is over here. Let's see if I have a pen. Yeah. So I trace that y value over. Right, that y value is the sine of 190. What other angles also share that y value? Well, if I keep just tracing across here, then I'm going to have another angle based on that point over here. Both of these points have the same y value. Right, that y value is whatever the sine of 190 degrees is. What's the reference angle here? Remember reference angles, that's the angle to the closest x-axis. The reference angle would be this angle right here in there. So it's 180 degrees to get to here, 190 to get to there. So the reference angle here, reference, there we go, angle would have to be 190 minus 180, yeah, which is exactly 10 degrees. So 10 degrees is that reference angle there. And because of the symmetry of the circle here, considering that point, which has the same y value right there, it has to have the same reference angle. So the angle over here on the other side, that also has to be 10 degrees. Now, if we think about how to measure, so when we're talking about an angle theta, that's usually the standard version of the angle. Standard version of the angle means start at the positive x-axis and go around counterclockwise. So 10 degrees is the reference angle. I could also call it -10 degrees would put me there, right? So 10 degrees is heading from this line to that line counterclockwise. -10 would be heading from the x-axis, positive x-axis down there. That would be -10 degrees. That gets me to this point here. Another way to get to that point is to go way around and come back here. Okay, what's that big blue angle? Well, 360 is all the way around, back up 10 degrees, and I got it. So my claim is that to get to this point here, which has the same y value as that point, then I would take 360 degrees, subtract 10 degrees, and my claim is must be 350 degrees. And let's check that on a calculator. Is it true that the sine of 190 degrees has the same value as the sine of 350? My picture leads me to believe that that is true. Let's whip out a calculator. And I'm going to try, let's see, I guess I can use, let's try this one here. All right, default here is that it is in radian mode. Let's see, I don't use Desmos much. How do we can turn probably the monkey wrench here? If we want degrees, we would have to go here and set degrees. So really, really, really pay attention to the mode of your calculator. Otherwise, you get weird stuff. So I need to change to degree mode if I want that to work. And I don't know how to silence my phone. Someday I got to learn how to do that. Sorry about that, guys. All right. I will learn how to do that soon. All right, so I'm in degree mode. Notice all those numbers change. So that's a problem with those. Don't ignore that up there. I want to know what is the sine of 190, and I get -0.17, and I think that's reasonable on my picture. Looking at my picture here, if this is -1 down here, yeah, that's around -1/10. or negative 0.2, negative 0.17. I'll buy that. And then we want to check what is the sine of 250 or 350, sorry. And it is the same number. And then I said I could also get to that place by going negative 10 degrees. So let's check that out. What's the sine of negative 10? And that should be the exact same number, right? All three are the same thing as we revolve around the circle. And that's something to get used to in trigonometry. There are many angles that get us to the same point. How many angles? Infinitely many. You can go round and round and round all day long and still get to the same point. All right, so back to my notes. And did I answer the right question? Let's zoom for a sec. You can go over there. All right, so it said find an angle between 0 and 360, right? So I found two angles. I found negative 10 and 350. It wants the one that is positive, right, between 0 and 360. So I'd have to say it's 350 degrees. Similarly, can we do that for the cosine? Answer is sure we can. Cosine means we just switch to working with x values instead. So if I focus now, choose red, x is the cosine of 190 degrees. We want to find an angle that gives me the same cosine. Now, I can't assume it's 350 because the sine and the cosine are two different things, x values versus y values. So here's my point right here for 190 degrees. And it has an x value that lives right up here, right? Pretty close to -1 there. What other point on the unit circle has the same x value? Well, I just keep tracing that x value past the axis up here, and I'm going to find another point right there. That point right there is going to be 10 degrees off of the negative x-axis here. So the reference angle for that point is 10 degrees, okay, but in that direction. Reference angles, we don't do direction, we just call them some positive number. So in this case, it's just 10 degrees. What's the actual angle, the standard angle to get to that point? Well, if 180 takes me to here and I just backed off 10, this angle right here, let's call it phi, would have to be 180 minus 10, which is going to give me 170 degrees. So I should find that the cosine of 190 degrees has the same value as the cosine of 170 degrees. Can I do this without drawing a picture? The answer is nope, got to draw a picture. Calculator time, check it out. Calculator, there you are. So if we check, what is the cosine of 190 degrees? We should see it's pretty darn close to -1. And then we want to compare that to the cosine of 170 degrees, and it is exactly the same number. So we nailed it. We found an angle within 360 degrees, positive, that gives the same cosine. Are there other angles that are going to give that same cosine? The answer is yeah, there certainly are. For example, if we look back at my picture, it's going to get a little messy. Just one more. I could start at the positive x-axis and go clockwise, which means I'm going to have a negative angle to get over there. So that means I would go 180 plus 10, right? So that'd be 190, but in the negative direction. So I should find that the cosine of -190 gives me the same thing. And you can see it gives the same value. And I could go all day finding angles that put me there. So one more, and then I'll shut up. If I were to start at the positive x-axis and then go around the circle in a positive way, which is counterclockwise, I could go around one time, keep going, and then I could stop here. So I went 360 degrees plus 170. What's 360 plus 170? Let's go to my calculator here. Where'd you go, calculator? There you are. Just going to check here. What is 360? I should be able to do this in my head, but I only had one cup of coffee. 530 degrees is the motion I made with my highlighter there. So I should check what is the cosine of 530 degrees. I can see it's that exact same x value, -0.9848, blah, blah, blah. All right, we did it. We kicked butt on that problem. Moving on. And we may as well get a Happy face, green check out of this. Bang, nice. If you do message me from these problems, remember my reply will show up here. It says, hey, you have mail. So either this is me writing to myself or somebody else wrote to me there, and I'll have to check on that later. And it doesn't matter which assignment you're on. So if you had a question on 5.3, but then you start 5.4, it's the same mail up here, and it is not the same thing as the Canvas inbox. Those are two different things.